from Desk of LADYADA.
Hey everybody, welcome to another Sunday evening Desk of LADYADA. It's me, LADYADA, here at my desk. With me is Mr. LADYADA behind this other desk where he does all the camera and video and audio control, answering questions. So come on by, we're here for about 30 minutes or so as we check what I've been up to this week, this weekend, stuff I'm looking at, hacking on. It's like super like raw and like unfinished.
That's right. This
on
is
my
the,
desk.
This is the unplugged, LADYADA Unplugged,
Yeah,
but it's also Desk of LADYADA.
Okay, cool. All right, well, let's kick it off. Do we have any news or updates for people, things they should know?
I'm hoping for a really boring week, everybody. So Wednesday is inauguration, and the Wednesday before that we had our live show, and lots of stuff went down. So hopefully we have a super boring day, and everybody stays safe, and we all get on to the next chapter because we're dying out here. Literally. So I'm hoping that everyone finds something to all rally together about. And one of the things that it could be is science and sharing and learning and coding and electronics. And maybe we want to colonize some of the solar system. There's only one way to do that, and that's together. So that's what I'm hoping for, is a really boring Wednesday. Monday, tomorrow, is Martin Luther King Jr. Day. Adafruit has the day off. Some of our team is taking care of some shipping, but it might take a little bit longer than usual. It's a day of service. Our teams do, it's a paid day off, but it's also part of what we do for the entire company. We have paid days off for charity. We'll have some things on our blog and more, so look after that. But aside from that, it's the whole show week. Tuesday, JP's show. You can watch live JP's pick from inside of a product page. Wednesday, we have 3D Hangouts. Then we have Show and Tell. Then we have Ask an Engineer. Then Thursday, JP's Workshop, and Friday, Deep Dive with Scott. And next week, on Wednesday, we have a hack chat, and it's going to be all about the ESP32S2. So look for that on Hackaday. They'll be announcing that really soon.
I'm going to talk about a little bit about some ESP32S2 stuff I'm working on already. So this is good timing. Okay.
So that's the news. And one thing I just want to tell everyone is I promise you that we're going to continue to do all the things we do, get products out, be good company, good business, open source. And I know we have some people in our community that are in DC right now, and it's a different DC than you're used to. But
we've been to DC a couple times. It's a beautiful city.
Yeah, we were there at the White House, 5 years ago, and looking forward to going back. So just hang in there, everybody. If we can do it, you can do it too.
Okay.
All right, so kick it off.
Let's kick it off. Okay, so following up last week, I was working on the Feather ESP32S2, and I kind of hit this weird stopping point where I was seeing, I wanted to basically verify that it would work well in low power mode. I wanted to focus on that because I have ideas for what this Feather could be good for that would be low power usage. And I noticed that I was getting these spikes of 4 milliamps every few milliseconds, even in the deepest sleep mode, and it was basically doubling my expected low power output. I was getting a little confused because was there some current leakage turning on a transistor, and I isolated it to the LC709203 battery monitor, and the data sheet says no, it should be drawing less than 2 microamps. So I was definitely what's going on here? I actually ended up emailing onsemi, because it was the maker of the chip, because I was your data sheet says this. There's no current draw information, but I'm definitely seeing these spikes. It's happening on multiple boards, so it's not there's a loose connection. And they said, oh, that's it. When it when you first turn it on, it draws up to 60 microamps while it classifies the battery, and it should go away after a minute. But because I was doing low power tests, when I plug it into the low power monitor, it was basically cold booting it every time, and that's why I was getting this higher power usage. So let's look at that on the computer. So one thing I've noticed is the PPK, the NRF power profiler, does not like it when I go in background mode. But here you can see what it should be. So you see about once every second or so, there's this little blip And there's like 2 blips. But for the most part, there's only 1 blip per second. And the average current draw is 35 microamps. And that's about as low as you're going to get for the ESP32S2 plus regulator, plus this battery monitor. Overall, like, yes, there's these little spikes to 4.5 milliamps, but they're happening so rarely that it doesn't affect really the overall power usage that much. So 35 microamps. This is a little bit hidden, but you can see 35 microamps. But what I was seeing is that if I turn off the power and then I turn back the power, so I'm actually writing some code that starts up and then it does some stuff and it goes into deep sleep mode. I was seeing these spikes and they were like every few milliseconds. So instead of once a second, this was happening. I was like, oh my God, my current is now 67, 68 microamps. Not okay. But it turns out that if you wait a minute, this calms down. So for low power usage, this is actually totally fine. Yes, it draws an extra 30, 40 microamps for the first minute, but it's worth it for it to classify the battery. And then when it goes into a deep sleep mode, after a minute of going into a deep sleep mode, it will drop down to a much more reasonable level. And we've definitely been having some like weird ADC read issues with ESP32S2. And I like that this even gives you the percentage of the battery and like you can do temperature sensing with it too. So it's, it's a nice little battery. So it's a battery monitor. So I'm glad that this ended up working out. So I can continue with this design and get this design fabbed. You can see now it's classified the battery. Now it's going down into the lower power mode for the battery monitor. So good stuff. I will be able to continue this design. I like the design overall. Let me show it on the overhead real fast so I can show people what I'm doing. So I've got the power profiler and it's connected through the battery monitor. So this is why I'm measuring the battery. ESP32S2, NeoPixel, BME or BMP 280, although I can kind of put any I2T sensor there. STEMMA QT connector that points up. Boot and reset button and all the analog charging circuitry and lots of GPIO pins and nice big ground plane as well. Kind of happy with how this feather turned out. So I'm psyched. As soon as I can get these modules, they're in sample zone right now, but once they're send me a reel of 1,000, I'll fab these. And it does work in CircuitPython. It doesn't have a lot of RAM, but it does work. I could get some basic stuff going with it. So this is good. I'm very happy with this. So I'm going to unplug this. One thing I did note is if you're trying out this, we have the STEMMA QT board version of this chip. If you're using it with the ESP32 S2 or maybe even the 32, I noticed it really requires repeated start. And when I'm using the latest Arduino ESP32 S2 Arduino board support package, it doesn't seem to be doing the right thing with repeated start, and like so few chips require it that like nobody caught it, but this chip does. So I open up an issue. Hopefully that'll get resolved very soon. Okay, so that's that. So I was testing with my Sele. One thing that I really like doing is I just connect up to one of these STEMMA QT sensors for debugging I2C, so I don't have to like solder any wires. I just plug this into the end of a board, and I was able to debug it. So that's good. Also did 2 STEMMA QT boards, and we even did a time lapse for the SHT40 and the, hold on, open this baggie. This is the ISO1540. So the SHT40 is a pretty high accuracy, high precision temperature and humidity sensor from Sensirion. It's their 4th gen. They did the SHT10, SHT2X series, SHT3X series, and now the SHT4 series. Simple I2T sensor. I feel like they really got it like nailed down. And then this board is kind of cool because it's like symmetric. You'll notice it looks the same forward and back. It's an I2C isolator. So these 2 ends are completely electrically isolated, which might be handy in some situations where you don't want to pass noise through them, or you have like a battery, you have a high voltage line and you don't want ground or earth to touch it, whatever. There's all sorts of times when you want to have totally separated data buses. So this is a fully isolated I2C connector. Ground, power, data, and clock are totally isolated, but you can still pass data at 1 megahertz or so between the two. Got
Question?
questions?
Yeah. Can that, or will it eventually work with CircuitPython?
The what?
I think the SHT.
Oh, I already wrote a driver for it.
All right.
It's already there. I just committed it today. So it's all working.
So speaking of how we bring up boards, we did a TikTok. And
That's
we're
right,
doing lots
kids.
of TikToks. So
We're there now.
I'm going to give you a heads up right now. Why don't you take out your phone and scan this QR code. If you have TikTok, scan the code on your left. If you don't, scan the QR code on your right. I'll go back to it after we talk about some stuff, but that'll open up our URL on TikTok, and it's just Adafruit is our username. And here's what we did, and then someone asked us a question, and we're going to answer the question now. So I took the sound off the TikTok on the side there.
But it's like bopping.
Because the way YouTube works is like any music someone else owns, even if we made it ourselves. Just the way it goes.
Yeah,
So,
because they own all music.
so what you see there is one of the videos on our TikTok, and it's LADYADA making a prototype here at home. And people really like these. The electronic community there isn't the same community as Instagram, which is more like, here's what I have, and here's how you should feel bad because you don't have it.
Yeah.
And then, YouTube, it's definitely like you have to be part of their machinery and like influencers and basically shill for brands and have a very different type of channel. And then TikTok, it seems like, and this is my observation right now, it's what you do. So there's a lot of young people in particular, and they're showing what they do and what they make. So it's a really neat community over on TikTok right now. And then after we posted this up, we take the video, whatever we put on one platform, we put it everywhere, except for, we'll make sure the music is not on some of them. And then Darian said on Twitter, I had a good question. How do you stop small components, resistor caps, from blowing away? That's the problem that I have when I'm using a hot air station, and I totally get the problem might be for me, or rather my technique. So LADYADA, how would you solve that?
What you want to do is you want to turn the air pressure basically to nearly zero. So hot air stations have like a range of like 1 to 10 for the air pressure, like how hard they blow air out. And you can't have it really past like 2, right? It has to be as low as possible while still getting air out of the gun. You want to bathe the area with air. You're not blowing air on it. If you're doing like heat shrink or other like, there are some situations where you want a hot air gun that has like a lot of air pressure, but I pretty much put the air pressure all the way low, the temperature all the way up, and then you also want to like slowly heat up the entire board. So you see, like I when I'm doing this, I start by kind of just rotating and heating up the entire board, and getting it kind of up to temperature, because you can't have too much temperature differential, or you'll have like popcorning parts that fly off. And then once I hit the whole board, you can see like I'm kind of like a circle around, and then I start at a corner and I move in, and I hit each part on the way from the outside to the inside.
So this is one of our ideas where we're going to post up videos, and y'all post questions for folks that aren't on live shows, and then we'll take the question and then we'll make a video about that, and we'll keep going, kind of like skateboarding. You do a trick, you do a trick. How do you do that trick? Let me show you how to do the trick. You show us tricks. The other thing is, and this is just part of our, outside of just electronics, wouldn't it be great to invest time and energy and resources so we could all learn how to talk to each other and think again? And we have a really good community. How about we all show everybody that you can get together, ask questions, learn, share, make stuff. I'm tired of waiting around. If not us, then who? So why don't we show everybody? So this is what we're doing, and we're going to keep doing this. And these are our ideas, and we're going to do this across all the platforms. So, got your phone? There you go.
Join us. It's cool. There's cool bops. Okay, so lastly, today after I finished all these drivers and hardware and things and power stuff, I installed Home Assistant on a Raspberry Pi 4. So you can see on my computer, you want to pop to the computers real fast. So this is Home Assistant running on a local installation. I've got the Philips Hue lights. We have Hue lights in this apartment, so we can like turn off all the lights really easily, or set them to be a nice warm color at night. We also have some HomeKit devices detecting, And it's got, of course, the Raspberry Pi stuff. So I'm just starting out with trying Home Assistant. I know a lot of people really like it. But one of the things I want to do is that ESP32 S2 Feather with a sensor on it and a STEMMA QT connector, I think would make a really great little node. So you could have the Raspberry Pi, and like that's your main station getting data over, Wi-Fi or Bluetooth, and then using that, storing that data locally. But then for the remote nodes, they could wake up, and the ESP32 S2 only has Wi-Fi. When the S3 is available with Bluetooth, of course, we'd support Bluetooth. But for now, it would wake up under Wi-Fi and then transmit, that data for, what the temperature, humidity, barometric pressure, or like air quality, and send that to your Home Assistant, and then you can do stuff with it. So I'm going to try to experiment with that next. So there's ESP Home and other ESP Home Assistant type plugins that I want to check out. Now, they're not for the ESP32 S2, but I think they're for the 32 because the S2 is really new. But I think we could probably port them over and make them work. So, very promising. I don't see why not.
Okay.
Okay, and lastly, so we're wrapping up this segment. I saw this cool teardown of an Echo Dot Gen 4. And I thought this was really interesting because when you're looking at something like the Echo Dot, it's something that has to be reliable. They do pretty good engineering with it. I've noticed that they don't use like totally weird parts. They use pretty standard parts for these builds. The quality is quite good, and it has to work very well. Like it sounds like a weird thing, but a lot of times you get like these like inexpensive electronics like voice assistant or like a Roomba clone, and they don't do a very good job. And it's like that 10% lower quality actually makes a difference in the user interaction. So I thought it was interesting. It's like, how could they make the most inexpensive audio assistant? And what's cool is, so they got this injection molding, and I thought this was neat. This was a little button board / microphone board, and like first off, like check out this cool ground plane stitching. I just love that, so cute. And then you can see the 4 microphones. So microphone 1, 2, 3, 4, and they look like PDM mics. And then they're connected to this ADC chip, ADC5140. And I was like, okay, well, like, what is it? Like, that's kind of interesting. So I wanted to look that up, find out about this, because we have a voice control bonnet for the Raspberry Pi that has 2 microphones. But if you want to do far field or like voice location projects, you kind of need 4 mics. Like 4 mics seems to be kind of the minimum. So if they were able to find a good, like whatever Amazon's using for this, they probably talked to TI and said, here's what we need for this to work well, for this low-cost device. And so if it works well for this application, it would work well for DIY and like student or research-based voice location and voice control projects. So it's kind of, I always like teardowns. I think you learn a lot from teardowns because some engineers spend a lot of time figuring this out and they can't hide it from you. So you can just like steal their time, take it for yourself. So let's look at quad I2S microphone amplifiers.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. LadyAda, what is the Great Search this week?
Okay, this week we're looking at quad microphone ADCs. So, oftentimes folks, when they're doing an audio interface, you have stereo, left, right. Microphone in, left, microphone in, right, line in, or maybe speaker left and right. It's not that usual that people have multiple audio inputs. However, this Echo Dot Teardown has 4 microphones because you need 4 microphones to do voice location. And on board is this chip, the ADC5140. It says TI on it, so I know it's a TI chip. And I thought, let's take a look at it and then maybe even make a breakout for this nifty chip, because if it's in the Echo Dot, it's probably a pretty good chip. So going to DigiKey, you can just search for ADC5140. And there's an eval board, and it's like $300. It's like $250. I'm sure it's a great eval board, and it has like this XMOS chip, which if you remember from INMPI, we talked about this XMOS chip. It takes the I2S data and actually does a lot of the algorithm work for you to like kind of automatically give you. They have like a ready to go program that takes this quad microphone data and gives you the location data. I think here's like the microphones are on the square here somewhere. Anyways, so let's check out the chip itself. So I2S codecs, even though I wouldn't necessarily call them ADCs and DACs, I mean, yes, they are, but they're kind of like not normal ADC and DACs because they use I2S. They're still under this special purpose ADC DAC data like I wouldn't normally call them data acquisition, but like technically they are. So just be aware that this is where I2S codecs live. Not a big deal, just so you know. And if we look up this data sheet, this is in fact a quad channel 768 kilohertz Burr Brown audio ADC. So the Burr Browns they're really nice quality. If you look into this in more detail, there's actually 3 chips in this family, the TLV 320 ADC X140. And each one of them has slightly different power supply rejection, or I think dynamic range. I'm trying to remember, but like they all have slightly different qualities, and you're going to pay more for the slightly higher quality versions. This chip is really neat because it's kind of straight to the point, and I like that. You have 4 inputs. You can have analog or PDM digital inputs. So I like that. You have a lot of choices. There's some power. It has a microphone bias output, really handy if you're doing electret mics to keep it nice and quiet. It has analog and digital control. It has a 1.8 volt regulator built in. So you give it 3.3 volts, and then you don't have to worry about giving it 2 power supplies. It'll handle the 1.8 for you. You can communicate with it over I2C or SPI. I2C tends to be a little bit more likely. Like I've seen more chips that are I2S codecs be controlled over I2C, but you never know. It's good to have SPI there. And here's the thing I really like about this. Besides the shutdown pin, which is very handy for when you want to, you keep it low so you don't have any noise come in. Especially for speakers, you want it to be muted. But you notice you don't need an M clock pin. You have F sync, B clock, and data out. And so you don't need an M clock pin, which makes it really good for use with a Raspberry Pi computer. There are some chips that don't have an M clock, or like driving the M clock for I2S is like it's unavailable, it's hard to use or something. Especially the Raspberry Pi, it's one of like the most popular boards that I use that does not have a master clock pin. So not needing it, because it has a PLL built in, is quite nice. So look for that. If you don't see M clock, you're good. This data sheet is quite long. So like, I was looking at this and I was making a breakout, and it goes on. Like there's a lot. There's like a lot of filters and settings, and like you kind of see this is like I'm getting into like page 60 and like 100, and I was like, well, I'm getting a little terrified to get this up and running. There is a Linux driver that's out of tree that I could use, but I was like, oh man, there's just so much configuration to do. Like look at like this mixer. Oh goodness. So I was like, well, maybe there's something. Although I really liked how simple the schematic was. I love this simplicity. So I was like, you know what? Let me look for some other quad ADC chips and see what I can find. So here's my quick tip. I can always get these. I did design a board for this in case. But let's go for an ADC. So DAC would be a speaker driver. ADC is a microphone driver. Active. I don't really care if it's I2C or SPI, so I'm going to leave that unchecked. I do want it surface mount, of course, and I want it to be 4-channel, quad channel. So I clicked that. And I don't need it to be part of this family. I just was like, well, what other quad microphone drivers are available? And this was kind of handy. So view similar. So, oh, by the way, you're wondering, like, well, how does this even work? Like, you have 4 channels of audio on a stereo I2S connection. It uses time division multiplexing, TDM, so that for each channel, it sends, multiple chunks of data. So, your driver has to know to read, 64 bits of data on each channel, and then you get the 32 bits out, or 16 bits on each, 32 bits on each channel. Cut it in half and you get 16 bits for each microphone, 2 on the left, 2 on the right, basically. But whatever. Okay, so let's look at what we've got. So what I thought was interesting is this. I don't know how this is sorted, but there was this chip right here, the PCM1840, and it's also a quad, it even says quad channel, 32-bit, 192 kilohertz audio. And it was even the same package, which I thought was neat, and it's I2S TDM. But notice that it doesn't say I2C or SPI, which I thought was interesting. So when I went to this board and I opened up the data sheet for this, if you look at the simplified block diagram and you look at this chip's simplified diagram, hold on. Gonna get there, is you'll notice that it's like, wow, they just totally use like the same graphics. But what really is going on is this is almost exactly the same chip. Now there's a couple differences in it, with the pinout, because the PCM1840, what's interesting is that it's almost pin compatible, but it doesn't have an I2C interface for configuration. Instead, it uses only bootstrapping pins. So FMT0, Format 0, and MD, which I think was Mode 0. There's these 1, 2, 3, 4, 5. These 5 pins, and that's how you configure the output. So you can set some different filters, and you can set up how you want the TDM I2S out to come out. And you can only use you can only use analog microphones. You can't use PDM, but it's a lot simpler to use. Datasheet's only 40 pages long. They show you, here's, there's a couple different settings. Look, you can only do 4 things with it. You can have it be, 4-channel output TDM, 2-channel. You can either have it be slave mode, which means something clocks it to get data out, or the other way around, where it pushes data out on its own clock. And I kind of liked that this was a just hardware bootstrapped chip. I thought this was a very interesting chip. So I'm glad that, when I looked at one chip that I thought was interesting, take a look around. See what other chips are in that family, even if this one has a totally different part name. But it turns out that this will work much better for me. It's less expensive. There's tons of them in stock. There's like 12,000 in stock or something ridiculous.
What's the price?
And this is about $225 in quantity. But it's got that reliability of a TI I2S chip. Can I find less expensive ones? Sure, but I want something that I know will work. And I know that TI, when they're making these for companies doing voice assistant. This isn't a new thing. TI and Burr Brown have been doing this for a long time, so I trust that I'll be able to get good data out of it. I won't have to worry about, as long as I follow their layout, I won't have to worry about noise creeping in or, like weird configuration settings. So this chip is really cool. I was really psyched to see this. So I picked this up, and here's the breakout that I'm designing for it to get started with experimentation. So because I don't need to write a driver for it, I can start up a Raspberry Pi and just load up the simple ALSA I2S driver with quad inputs and TDM multiplexing, and then I can just pipe the data in, and I'm going to see, hopefully it'll just work, and that'll be really cool because I don't want to have to deal with the kernel driver if I don't have to. So that's my great search chip. Today's tip is always look for similar chips. Even if the part number is not the same, you might find something better than what you've already found.
That's a good search.
1840. Digging it.
Where in the world is that part I need? The great search with DigiKey.
All right, here's some
Okay.
questions
Yeah.
and some comments.
Great.
So first up, we had a UVC sensor that we were working on, right?
Yeah, the LTR390. It's in the store.
In the store.
We did it.
All right.
It's done.
That's from Natalie's girl, so it's in the store. Any thoughts of a cell breakout for Featherwing? Well, I can tell you there's a bunch of challenges with cell right now. The modules are huge and they take a lot of power and they're expensive.
If you're using 4G, 3G or LTE.
Yeah.
Or you can go with NB-IoT, but that's not supported everywhere.
Yeah,
So,
we're in
this
the
annoying-
brackish period between freshwater and saltwater, or vice versa. If I had to suggest something, if you're in a jam, check out Particle.
Yeah.
Speaking of, is LADYADA sure?
Well, sure.
Okay.
But they do everything for you. Look, it's not going to be as inexpensive as 2G, but it definitely works.
Folks like ESP Home makes it really easy to make an ESP-based home assistant on generic MQTT modes.
Cool.
Just have a YAML file and that glues together a bunch of code and it builds with Platform IO.
Yeah, I thought it would be neat, like maybe in CircuitPython we could just parse that YAML file.
Okay.
You know what I mean? So it just works out of the box.
Next up, folks like the Great Search. How many layers is a cutie pie?
2-layer.
Okay. And I think that's going to be the questions.
Okay, cool. All right, we got everything.
Yeah. Oh, Electric Ib is one with Twilio. There is some part you could look who uses that connectivity. Yeah, Electric Ib. Like, remember them? They did the Wi-Fi
Yeah.
stuff inside of like
I
air
guess they're doing
conditioners and
cellular
stuff.
now,
Yeah.
maybe.
All right. So that's
All right, cool.
Desk of LADYADA this week. We'll see everybody next week. If you want to follow us on TikTok, we'll be up to like 5,000 people already, and these are like a lot of people who make things. The comments are great. I don't know if things are going to change or why they're so good right now, but I'm going to enjoy it briefly or longer. Who knows? So thank you everybody for joining us tonight. We very much appreciate it.
Yay!
Thank you for supporting us during all of these times and placing orders and all that stuff. And we'll see everybody next week, no matter what, because that is what we do.
We'll be here.
All right.
All right, thanks everybody.
Bye.